Good morning. Let's continue with yesterday's topic, trigonometric ratios and identities. Yeah, yesterday we solved a few problems related to trigonometric identities and trigonometric ratios. Let's continue with that. And the last problem was e to the power of sine square x plus sine to the power of 4x plus sine power 6x. And five homeworks we had yesterday. Yeah, one of the homework problems you find sine of alpha plus beta, trigonometric ratios and identities. Yeah, we had a question in homework like sine alpha plus beta is 1 and sine of alpha minus beta is 1 by 2. That is alpha plus beta you are taken as 90 degrees, alpha minus beta is 30. When you solve these two, you get alpha as 60 and beta as 30. After you will substitute in tan of alpha plus 2 beta and tan of 2 alpha plus beta. The result is 1, you got it. Result for sine alpha plus beta equal to 1, sine alpha minus beta equal to 1 by 2. Then tan 2 alpha plus 2 beta and tan 2 alpha plus beta, the result is 1. This was one of your homework questions. And one more was, it is sine square 51 minus x. Sine square of 51 minus x degrees, 51 minus x degrees, and plus sine square 39 plus x. Sine square of 39 plus x. This was one of the homeworks again, for which we have used the concept. What is the concept we have used for it?
A plus B equal to 90.
Yeah, a plus b is 90. If a plus b is 90, that is your sine square a plus sine square b form. Sine square a plus sine square b form. Now, whenever sine square a plus sine square b here, we first check what is the value of a plus b. A plus b. If a plus b is coming to 90,
is equal to 1.
yeah, if a plus b is 90, then sine square a plus sine square b is equals to sine square a plus sine square b is 1. Yesterday we had written as a concept. Yesterday in concept we had noted that if a plus b is 90, then sine square a plus sine square b is 1. Now we check this is your a value. This is your a value. And this is your b value. So a plus b. A plus b is 51 minus x plus 39 plus x, which is coming to 90. Which is coming to 90. So since a plus b is 90, sine square a plus sine square b will be 1. So sine square of 51 minus x plus sine square of 39 plus x. This value is 1. This was your homework, one of the homeworks. And one more we had 8 sine square x plus 3 cos square x equals to 5. 8 sine square x plus 3 cos square x is equals to 5. This was one of the homeworks again. How to find the value of cot x from here? The value of cot we need to find. 8 sine square x plus 3 cos square x equal to 5. To get cot square x, you need to divide both sides by sine square x. Divide both sides by sine square x. So this will become 8 sine square x by sine square x is 8. Yeah, 3 cos square x by sine square x is cot square x. Cot square x. And this will be 5 by sine square x. 5 by sine square x. So 8 plus 3 cot square x is equals to 5 into 1 by sine square is cosecant square x. Now again cosecant square x can be written as we have an identity. What is that? Cosecant square x minus cot square x. Cosecant square x minus cot square x is 1. So cosecant square x can be written as 1 minus 1 plus cot square x. 1 plus cot square x. Okay. So cosecant square x is 1 plus cot square x. Now, simplifying it further, 8 plus 3 cot square x is equals to 5 plus 5 cot square x. Now, transposing 8 minus 5 is equals to 5 cot square x minus 3 cot square x. So you remain with 2 cot square x is equals to 3. 2 cot square x is 3. So cot square x is 3 by 2 from here. And cot is plus or minus under root of 3 by 2. That's the result. Make a note. Just mention the identities beside. Mention the identities beside. Now, one more question we had. There's one more question. That is sine 10 plus sine 20. One more homework problem we had. Sine 10 plus sine 20 plus sine of 10 degrees plus sine of 20 plus sine 30 plus so on till sine of 360. Sine of 360. Yeah.
Sine A plus B equal to 360, then it will be equal to 0.
Yes. Before sine 360, we have got sine of
350.
350. Again, before it, we have sine of
340.
340. Sine of 340. Okay. So when I add this A plus B of these two terms, this is your A value. This is your A value. Okay. And this is your B. This is your B. This is your B. Now, if I add these two, A plus B is 360. Whenever A plus B is 360, then what is sin A plus sin B?
0.
Yeah, sin A plus sin B will be 0. Whenever A plus B is 360, sin A plus sin B is 0. So, sin 10 plus sin 50 will be sin 10 plus sin 50 is 0. Sin of 350. Sin 10 plus sin of 350 is 0 because A plus B is 360. Same way, sin 20 plus sin of 340. Sin 20 plus sin of 340. Again, A plus B is 360 here, isn't it? This is your A, this is your B. A plus B is 360, then sin A plus sin B is 0. Similarly, sin 30 and sin 330, sin 40 and sin 30 and sin 330, sin 40 and sin 320. So this way, these all pairs will be zeros. And last we have again sin of 360. Sin of 360. What is sin 360 again? Value of sin 360 is 0. Sin n pi is 0. Sin n pi value is 0. For all n belongs to z. For all n belongs to z, sin of n pi is 0. This is 2 into pi. 2 into 80, 180. 2 into 180, which is sin of 2 pi. So sin n pi is 0. Sin 2 pi is also 0. Okay. So The result of all this is 0. Make it up. Just highlight the concepts. This is one, this is the other. Make it. Yeah. Now we want one more question. If sin x plus cos x equal to a, make it out please. Sin x plus cos x is equals to a. This is today's answer. If sin x plus cos x is equals to a, then the modulus value of sin x minus cos x, modulus of sin x minus cos x, what is given is sin x plus cos x is a, then what is the modulus value of sin x minus cos x, sin x minus cos x. Now I take this condition, sin x plus cos x is given as a. I go for squaring on both sides. Squaring on both sides. This is sin x plus cos x whole square is equals to a square. Sin x plus cos x whole square equals to a square. Now this is a square plus b square plus 2ab, 2 sin x cos x is equals to a square. Now, the sin square x plus cos square x is the identity 1 plus, 2 sin x cos x is, 2 sin x cos x is sin 2x. Sin 2a formula is 2 sin a cos a, 2 sin a cos. So, 2 sin a cos a is sin 2a is equals to a square. From here, I get the value of sin 2x as a square minus 1. We got the value of sin 2x as a square minus 1. Now let's use that modulus value. Modulus of sin x minus cos x. Sin x minus cos x. This can be written as plus or minus root of sin x minus cos x whole square. Can it be written? Yeah. Why? Because when you remove the modulus, you will get it definitely plus or minus. So it is under root of sin x minus cos x whole square. Now, again, this is an a minus b whole square form. This is an a minus b whole square form. So a square plus b square minus 2ab, 2 sin x cos x, 2 sin x cos x. So which is under root of again sin square x plus cos square is as per identity 1 minus sin 2x. What is sin 2x we have?
A square minus 1.
The substitute. Substitute sin 2x as a square minus 1. Make it up. What is it?
A.
So substituting sin to x, A is the answer.
Yes.
Let's take it out.
Plus or minus.
Let's take it out. It is 1 minus, yeah, sin to x value we have as
A square minus 1.
in brackets. A square minus 1 in brackets. Okay. So minus of a square minus 1, which is 1 minus a square plus 1, which comes to 2 minus a square. That's the result. 2 minus a square. Root over 2 minus a square. Next question. Yeah. Two arcs of same length of two different circles. Make a note. Two arcs of same length. Two arcs of same length of two different circles. Of two different circles. Subtend angles 25 and 75. Subtend angles 25 degrees and 75 degrees at their centers. 75 degrees at their centers respectively. At their centers respectively. Then the ratio of the radii of the circles. Then the ratio of radii of the circles is ratio of radii of the circles is. Now you have two arcs which are of same length. You have two arcs which are of same length. Okay, of two different circles. They subtend. These arcs they subtend angle of
25.
Yeah, we have two arcs of circle. One circle, I have an arc of circle which is making an angle of 25 degrees at the center, which is making an angle of 25 degrees at the center. There is an arc which makes an angle of 25 degrees at the center. This is the arc, making an angle of 25 degrees at the center. Say we have one more circle which makes an angle of
75.
Yeah, one more circle which is making an angle of 75 degrees at the center. One more circle whose arc makes an angle of 75 degrees at the center. Now, our question is two arcs of same length of two different circles. Two arcs of same length of two different circles. Now, lengths of the arcs are equal. Now, we have the relation that length of the arc L is equals to R theta, yes, exactly. Length of R, L is equals to R theta. So what is R from here is R is equals to L by theta. L by theta. Now let us find what is the ratio of these two radii of these two circles. Ratio of radii of the circles. Ratio of radii of the circles. So we must find what is R1 by R1 by R. What is R1? R1 will be L
by 25.
L by theta 1. L by theta 1. Okay. L by theta 1 by yeah, both are of same length. Na? Two arcs are of same length. So the second arc, the length of the second arc is also L by angle is theta. Angle is theta. So this will become theta 2 by
theta 1.
theta 2 by theta 1. ln eliminated theta 2 by theta 1, which is 75 by
25.
so ratio is 3:1. Therefore, R1 is to R2 is 3:1. Make it up. Make a note. Okay. The next one. If alpha, comma, beta are complementary angles, make it work. Alpha, comma, beta are complementary angles. And sin alpha equal to 3 by 5. Sin alpha equal to 3 by 5. Then find the value of sin alpha cos beta cos alpha sin beta. Sin alpha cos beta minus cos alpha sin beta. Alpha and beta are given as complementary angles. Then what is the value of sin alpha cos beta minus cos alpha sin beta? Yeah. Sin of alpha minus beta, but alpha minus beta isn't given. Na? Okay, no doubt. Sin alpha cos beta minus cos alpha sin beta is sin of alpha minus beta. But is alpha minus beta value given? No. Alpha beta are complementary angles. Alpha plus beta value. The complementary, so we know alpha plus beta. But here I need sin of alpha minus beta. So sin of alpha minus beta, can I find it? No. Alpha minus beta isn't given. Alpha minus beta isn't given. Alpha plus beta is given. Alpha beta are complementary. Alpha beta are complementary, so alpha plus beta is 90. From here, beta is nothing but 90 minus alpha. 90 minus alpha. So cos beta will be cos of 90 minus alpha, which changes to cos 90 minus theta is sin theta. So sin alpha. Okay, the same way sin beta is equals to sin of, yeah, beta is 90 minus alpha. Beta is 90 minus alpha. So sin of 90 minus alpha, which is, yeah, sin 90 minus alpha is cos alpha. So let's substitute back here. So sin alpha into cos beta is again
Sin alpha.
cos beta is again sin alpha. So sin alpha into sin alpha minus
Cos alpha into cos alpha.
cos alpha into, yeah, sin beta is equals to cos alpha. So it is sin square alpha minus cos square alpha. Sin square alpha minus cos square alpha. Now I know the value of sin alpha. What is sin alpha is 3 by 5. What will be cos alpha then? Sin alpha is 3 by 5. How to find cos alpha? Yeah. Right angle triangle, you can take it, okay, and apply Pythagoras theorem. Sin is opposite by hypotenuse. Okay, then you can find the adjacent side. Cos alpha will be adjacent by hypotenuse. If not, you can find by under root of, yeah, cos alpha is under root 1 minus sin square alpha, no? From the identity. Cos alpha is under root of 1 minus sin square alpha. So it is under root of 1 minus sin square alpha is 9 by, this comes to 25 minus 9, 16 by 25, which is 4 by 5. So cos alpha value is 4 by 5. Sin alpha and cos alpha, both we have now. Sin alpha is 3 by 5. Sin alpha is given as 3 by 5. Next we got the value of cos alpha as 4 by 5. Substitute both the values. Substitute both the values. Sin square alpha is 9 by 25. Cos square alpha 16 by minus 7 by, you note this complete. You have to note, make a note of this also. Completed. In the next question, one more. If cos A, sin A, cot A are in GP, this is fourth one. Today's classroom, the fourth one is. If cos A, comma, sin A, comma, cot A, sin A, comma, cot A are in GP, are in geometric progression, then you need to find the value of tan power 6a minus tan square. Tan power 6a minus tan square. All these three are in GP. We have three terms in GP. One is cos A, sin A, and cot A are in GP. Now we have a concept that if A, comma, B, comma, C are in geometric progression, are in GP, then yes, if A, comma, B, comma, C are in geometric progression, then yes. If A, comma, C, comma, A, comma, B, comma, C are in geometric progression, what is geometric progression? Common ratio usage, isn't it? So you have a sequence like 2, 4, 8, 16. 2, 4, 8, 16. Now check that. Here you are multiplying this first term with some fixed number 2. You are getting 4. Again 4 you multiply the same fixed number. Okay. 8 you are multiplying the same fixed number. Again 60 if you multiply the same fixed number you get 32. This fixed number is called, yeah, this is called as common ratio. The fixed number is called common ratio denoted as R. Common ratio denoted as R. Now, this sort of sequence we call it as GP. Now you take the three terms of it, 2, 4 and 8. It's like A, comma, B, comma, C. A, comma, B, comma, C. Check that the value of B square will be same as AC. B square value. What is B square here? 4 square. AC is 2 into 8. Yes. 16 equal to 16. So B square equal to AC is the condition whenever you have 3 terms in GB. Whenever you have 3 terms in GB, then what is the condition we have? B square equal to AC. B square equal to AC. Okay. Now, what are the 3 terms in GB now? Cos A, comma, sin A, comma, cot A are in, they are in geometric progression. Now, if they are in GB, B square value, that is sin square, is equals to A into secant, cos A into cot A, cos A into cot A. Now, cot is sin square A is equals to, yeah, cos A into, yeah, cos A by sin. Okay. Now, this is cos square A by sin square A is equals to cos square A by sin A. What I do is this cos square A I get in denominator. That is, I divide both sides by cos square A. I divide both sides by cos square A. So this will become sin square A by cos square A. I'm dividing by cos square on both sides, isn't it? So, yeah, cos square will cancel 1 by sin A. 1 by sin A, which is cosecant A. And here I get sin square A by cos square A is tan square. So, tan square A is cosecant A. The value of tan square is cosecant A. Our question is, we have to find what is tan power 6A minus tan square. Tan power 6A minus tan square. So let's find now. Tan power of 6A minus tan square A is equals to, I can write this as tan square A whole cube minus tan square. Yeah, what is tan square A is cosecant. So this will become cosecant cube. This is cosecant. Cosecant to the power of 3. So cosecant cube A minus tan square is cosecant. Tan square is cosecant A. So cosecant is common. Cosecant is common. Cosecant A into cosecant square A minus 1. What is cosecant square A minus 1? Yeah, cosecant square A minus 1 is cot square. Cot square, which is nothing but cosecant A into cot square is 1 by tan square. Cot square is 1 by tan square. What is tan square again we have?
Cosecant.
So this will become cosecant A into
1 by cosecant.
1 by, yeah, tan square value we have here. Tan square value we have here. From this relation, all the three in GP, tan square is cosecant A. So tan square A can be substituted as cosecant A. Cosecant A, cosecant A, and the result is 1. Make a note. If I go for the note verification, let's get into the process. And this should be doubt these functions. Yeah. If f of x is equals to, this is question number 5. F of x is equals to x square minus 3x plus 5. X square minus 3x plus 5. Then f of sine 3 pi by 2. Then f of sine 3 pi by 2 plus f of cos 3 pi by 2. F of cos 3 pi by 2. We'll find this result. Very simple. You find what is the sine 3 pi by 2 first. Sine of 3 pi by 2 is, yeah. Again, write here sine of 3 into pi by 2 minus 0. Now, this is like sine of n pi by 2 minus 0. Yesterday we had written the concept. It is sine of n pi by 2 minus 0, where n is an odd number. If n is odd, this number is odd. So if this odd multiple of 90 we have, then you get the co-ratio of it. Instead of sine, you get cos 0. Cos 0. Okay, plus or minus cos theta it is. Plus or minus cos theta. Here you take only plus y because plus or minus here. 3 into pi by 2 is 270. Right? It's like 270 minus 0. 270 minus 0. 270 minus 0 lies in third quadrant. And in third quadrant, sign is negative. So you get minus cos 0, which is minus 1.
We write it as 360 minus
Can we write it as 360 minus
9.
360 minus, we are writing multiples of 90. So this value theta should be again lesser than 90. When we write multiples of 90, this value will be in between 0 and 90. Okay. So next one, cos 3 pi by 2. Cos 3 pi by 2. Again, this is cos of 3 pi by 2 minus 0. Again, this is odd multiple. Odd multiple of 90. Instead of cos, you get sine 0. Sine 0. You get a co-ratio. Co-ratio. Yesterday we are in the concept. Okay. So, and this is again 270 minus. 270 minus is third quadrant. Third quadrant cos is negative. Anyhow, sine 0 is 0 itself. You write minus 0 or 0. Now, you find the value of sine 3 by 2 is minus 1. So it is f of minus 1. F of sine 3 by 2 is nothing but the value of f of minus 1. F of minus 1, which is minus 1 square, 3 into minus 1 plus 5. 1 plus 3 plus 5, which comes to 8. Similarly, what is f of cos 3 pi by 2? F of cos 3 pi by 2 is the value of f of 0. F of 0 is 0 square minus 3 into 0 plus 5. Result is 5. Now adding these two. F of sine 3 pi by 2 plus f of cos 3 pi by 2.
8 plus 5.
Yeah. Answer is 13. Make a note. You need to note this also. Note this. One more question. A secant theta plus B tan theta equal to C. A secant theta plus B tan theta equals to C. A secant plus B tan equal to C. Then what is A tan plus B secant whole square? A tan theta plus B secant theta whole square. A secant theta plus B tan theta is given as C. Our question is what is A tan theta plus B secant theta whole square? Now let us take this condition first. Squaring on both sides. Squaring on both sides for this condition. A secant theta plus B tan theta whole square is equals to C square. So this is A square secant square theta plus B square tan square theta. Okay. Next 2AB secant theta tan theta is equals to C square. Is equals to C square. This is from the first relation. Now, A tan theta B secant theta whole square will have some value, isn't it? This A tan theta B secant theta whole square. This will have some value. Let us assume that value as K. A tan theta plus B secant theta whole square has some value. Let it be some K. Now, let's apply A plus B whole square, so it is A square tan square theta plus B square secant square theta, 2AB tan theta into secant theta is equals to K. This you name it as equation number 2. Now, if I subtract these two, then 2AB secant tan, from here 2AB secant tan will cancel. Okay, then I'll get secant square theta minus tan square theta. If I subtract 1 and 2, subtracting 1 and 2, so I get, if I subtract these two, A square is common, A square into secant square theta minus tan square theta. Next, if I subtract these two again, B square is common, tan square theta minus secant square theta. Tan square theta minus secant square theta. And here, these two will get cancelled. When you subtract it, these two get cancelled. You remain with C square minus K. Now, secant square minus tan square is 1. What about tan square minus secant square is minus 1 is equals to C square minus K. This is A square minus B square is equals to C square minus K. Our question is finding K value. Finding the value of K, that is A tan plus B secant. Transposing it. K is equal to C square plus B square minus A square. Make a note. Homeworks you got. Homeworks. Cosecant plus 40 equals to 2 by p. Then what is cos? Written the concept yesterday. You check it out. Tan theta comma 2 tan theta plus 2 comma 3 tan theta plus 3 are in GP. Then 7 minus 5 cot theta by 9 minus 4 under root of secant square theta minus 1 is equals to. Okay. And we have to prepare the formula and compound angles only related to compound angles. Because tomorrow we are going to start with compound angles. Compound angles. Okay. What is sin A plus B, cos A plus B, sin A minus B, cos A minus B, what is tan A plus B, tan of A plus B plus C. Okay, if it is a sin of A plus B plus C. So all these compound angles you need to prepare. You have in your 11th textbook, you just prepare, make a list of it, all the compound angles formula. Okay, then we'll continue tomorrow.
There's something moving there. Na? Okay.
నువ్వు పొద్దున కాల్ చేసావు కదా రావడానికి కాల్ చేసావా మమ్మీ తీసేసి మా మమ్మీ ఏమో నేను ఇంకా లేవని అనుకుని మీకు అడిగింది రేపు వస్తావా ఏదైనా రేపు మమ్మీ చిన్న బయట ఆన్లైన్ ఆఫ్లైన్ రెండు ఉన్నాయి నేను ఇక్కడ కూర్చున్నాను క్లాస్లో కూర్చున్నాను ఆన్లైన్ నువ్వు ఇప్పుడే లేచావా క్లాస్ చూసావా హలో But we will watching చూసావా equal to 0. చూడు సైన్ అయితే సైన్ ఈక్వల్ టు 0 నా I don't have
Good morning, all of you. Benefits. Yesterday we discussed the nomenclature of halo compounds. We go for alcohols, alkylating alcohols. Alcohol's function is OH. OH is the function group of alcohols. Suffix for alcohol is ol. Then IUPAC name for alcohols is alkanol. Alkanol is the IUPAC name of alcohols. Let's see first. Single alcohol is CH3OH. Commonly, you take IPAC. Common name is methyl alcohol. IPAC is methanol. Next, second. CH3CH2OH. Common name is ethyl alcohol. Ethanol. IPAC. CH3CH2OH. N-propyl alcohol. Common name is N-propyl alcohol. IPAC is propanol. The numbering more than 2 carbons are there unless you take numbering. So always keep to this number for functional groups 1 propanol. Next, alcohol's functional group is OH. Suffix O, IPAC name is alkanol. Methyl alcohol, methanol, ethyl alcohol, ethanol, and propyl alcohol. Next, so common name for this isopropyl alcohol. IPAC name is 1, 2, 3. 2 propanol. 2 propanol. R. Propan, 2. Both are correct. So IPAC name is 2 propanol. Common name is isopropyl alcohol. This secondary propyl alcohol also another common. Isopropyl alcohol or secondary propyl alcohol. IPAC is 2 propanol or propan 2. Alcohol dihydroxy alcohol. So here is CH2OH, CH2OH. Name of this compound is ethylene glycol. Ethylene glycol. The common name is ethylene glycol. IUPAC is ethane. Here 1, 2 positions alcohol is present. So ethane 1, 2 dipole. If 3 hydroxy groups are present, this is trihydroxy alcohol. 3 hydroxy groups are present. 1, 2, 3 positions. This will be called as common name for this. Glycerol. IPAC is propane 1, 2, 3 thiol. Is our copy this. 1, 2 dihydroxy compound, ethylene glycol. 1, 2, 3 trihydroxy called as glycerol. Propane 1, 2, 3 thiol. Glycols, glycerol. Next, carbonyl compounds. Nomenclature for carbonyl compounds. Here, carbonyl compounds are two types: aldehydes and ketones. Aldehydes, ketones. Aldehydes function are CH, C double bond OH, nothing but CHO. Ketones function is C double bond. Here one side R means carbon, here both sides carbon. Ketones, aldehydes is called as carbonyl compounds. Aldehydes suffix is al, A. Ketones suffix is O. So IUPAC name for aldehydes is alkania. Alkania. Alkania is the IUPAC of aldehydes. Ketones IUPAC name is alkanone. Alkanone is the IUPAC name of ketone. Carbonyl compounds two types: aldehydes and ketones. In aldehydes, one side carbon, other side is hydrogen. Simply write that CH2 is the function. Here ketones function we write that like here both sides are carbonyl function. Carbon is present. Here suffix is there. O. IUPAC alkania. Is all of you copy this? Take aldehydes, different aldehydes. First, formaldehyde, HC double bond of H. Common name is formaldehyde. IUPAC is formaldehyde. The common name. IUPAC name for this is methania. Here one carbon is there, that's why meth is the root word. Al is the suffix. So methania is the IUPAC name of this compound. The next CH3C double bond H. Name of this compound is acetaldehyde. Acetaldehyde is the common name. IUPAC here, two carbons are there. So alkania is the IUPAC. Here two carbons are there. So the nya, the IUPAC name of propanaldehyde. Then propanaldehyde. One propanol is IUPAC. Formaldehyde, acetaldehyde, methanol, methanol. If you write up to 5 hours. So propanol decay, butyrol decay, pentanol decay. Next, ketones. Okay. So commonly IUPAC. This acetone is the common name. Acetone is the common name. IUPAC name is propanol. Propanol is the IUPAC. Acetone is the common name. The name is one number. This butanol or methyl ketone is the common name. Methyl ketone. We call it methyl ketone is the common name. IUPAC is butanol. So the carbonyl compounds are lipids ketones. Like the pentanol, hexanol, like that. Next, aromatic compounds. Okay. Aromatic aldehys, aromatic ketones. Name of this compound is benzoaldehyde. Benzoaldehyde is the name. This acetophenone. Name of this compound is sulfilaldehyde. Benzoaldehyde, acetophenone, sulfilaldehyde. Next functional group, carboxylic acids and derivatives. Carboxylic acids and their derivatives. Acidic carboxylic acids. Functionally represented as COOH or C double bond OH. Suffix for this oic acid. Oic acid is the suffix of carboxylic acid. IUPAC name is alkanoic acid. Alkanoic acid is the IUPAC. Functional group is COOH. Suffix is oic acid. IUPAC name is alkanoic acid. HCOOH. Common name IPAC. Common name for this is formic acid. Formic acid is the common name. IUPAC is one carbon acid, so methanoic acid. Alkanoic acid is the IUPAC, so one carbon acid, so methanoic acid. Next, increase one carbon, CH3CO. Common name is acetic acid. Acetic acid. Acetic acid is the common name. Another one also there is vinegar. Vinegar is nothing but acetic acid only. IUPAC is ethanoic acid. Ethanoic acid. Like that, propanoic acid, ethanoic acid. Formic acid, acetic acid. Increase the number. Propanoic acid, butanoic acid, pentanoic acid. Next, carboxylic acid, aromatic carboxylic acid. Please all of you copy this. Some aromatic carboxylic acids. Aromatic. Name is benzoic acid. You take dicarboxylic acid, talic acid. Isotalic acid. Tephthalic acid. Here this is orthohydroxy benzoic acid. Common name for this is salicylic acid. Salicylic acid. Benzoic acid, salicylic acid, isotalic acid, tephthalic acid, salicylic acid. Orthohydroxy benzoic acid, common name salicylic acid. Then take groups. HC double bond group we call as formyl. It is formyl. CH3C double bond group we call as acetyl. Formyl acetyl. Acetyl salicylic acid. So we call as acetyl salicylic acid. So here common name is aspirin tablet. Aspirin used as a antibiotic. Acetyl salicylic acid. Just carboxylic acid derivatives. Acid halides. Amide, acid amide. Simply called as amide also. Amide, ester, acid anhydride. These are the carboxylic acid derivatives. Acid halide, acid amide or simply amide, ester, acid anhydride. Next, acid halide, amide, ester, acid anhydride is the derivatives of carboxylic acid. Heading acid halide. Here, function group represents as C double bond to X. X here is halogen. Chlorine, chlorine, bromine. X is acid halide. So here suffix is oil halide. IUPAC is alkanoid halide. Alkanoid halide. Alkanoid halide. Next, alkanoid halide is the UPAC. Common name for this IPAC. Formyl chloride. Formyl chloride is the common name. IUPAC is methanoyl chloride. Methanoyl chloride. Common name for this is acetyl chloride. Acetyl chloride is the acid halide. IUPAC is ethanoic chloride. These are the particles. Amide. Acid amide, simply called as amide. Amide. Function represents as C double bond O NH2. This is suffix for this. Amide is the suffix. IUPAC is alkanamide. Alkanamide is the suffix. Alkanamide is the IUPAC name. Two examples. HC double bond over NH2. Common name. IUPAC. Common name for this is formamide. Sorry, formamide is the common name. Methanamide is the IUPAC. Methanamide is the IUPAC. Okay, this name is acetamide. Acetamide. Ethanamide is the IUPAC. Formamide, acetamide, methanamide, ethanamide is IUPAC. These are the copies. Next. Next derivative. Ester. Next acid derivative. Ester. So functional group is RC double bond OR. IUPAC name is alkyl alkanoid. Alkyl alkanoid. So C RC double bond OR. Here this is alkyl. This is alkanoid. Alkyl alkanoid is the IUPAC name. Alkyl alkanoid is the IUPAC name of ester. Take examples. HC double bond O OCH3. Common name. IUPAC. Methyl formate. Methyl formate is the common name. IUPAC is so alkyl alkyl. So methyl here. So how many carbons are there in alkyl alkyl? One. So here we get methyl methanoate. Methyl methanoate is the IUPAC. Methyl methanoate. English one carbon. Ethyl acetate. Ethyl acetate is the common name. IUPAC is ethyl ethanoate. Methyl. So here methyl. How many carbons are there in this? 2 carbons. So here we get ethanoate. The bases. Methyl formate, methyl methanoate, methyl methanoate. Ethyl acetate is the common. The ester. Alkyl alkanate is the IUPAC name. Next. Acid derivative. Acid anhydride. RC double bond O R. IUPAC is alkanoic anhydride. Alkanoic anhydride. Example: HC double bond O. So this anhydride is coming from formic acid. So common name IUPAC. Common name is formic anhydride. It's coming from formic acid. So formic anhydride is the common name. IUPAC is here. One carbon is there. So here we get methanoic anhydride. Methanoic anhydride. Important one is acetic anhydride, very important. So here ethanoic anhydride is the IUPAC. These are the derivatives: acid halides, amides, ester, and acid anhydrides. These are the properties. So IUPAC is alkanoic anhydride, this is formic anhydride, methanoic anhydride, this is IUPAC, acetic anhydride, and ethanoic anhydride is the IUPAC. These are the acid and acid derivatives. Aromatic. This group we call as benzoyl group. benzoyl group. Benzoyl group. We call as benzoyl chloride. Benzamide. Benzoyl group. We call it benzoyl chloride. Benzamide. Benzamide. Next. Amines. The function represented as NH2. Suffix is amine. IUPAC is alkanamine. Alkanamine is the IUPAC. Function represented as NH2. Suffix is amine. IUPAC is alkanamine. Next. Examples. Common name IUPAC. Common name is methylamine. IUPAC is methanamine. Take methylamine. Methanamine is the secondary amine, primary son of primary amine. The secondary. So primary amine means nitrogen directly attached to one carbon we call as primary. Nitrogen attached to two carbons we call as secondary amine. This is secondary amine. Right? Secondary amine common name. Right as N-methyl. And nitrogen methyl substituent is there. N-methyl. N-methyl methylamine is the common name. N-methyl methylamine is the common name. IUPAC is N-methyl methylamine. These are the components. So nitrogen directly attached to one carbon we call as primary amine. If nitrogen is attached to directly two carbons we call as secondary amine. Right? Secondary amines common name take N-methyl methylamine, N-methyl methylamine. If we take one tertiary amine, nitrogen attached to three carbons around. And this is tertiary amine. Here nitrogen attached to 3, 1, 2, 3. So for this common name is N-carmine dimethyl methylamine. the common name N-gamma and dimethylamine. IUPAC is N-gamma and dimethylamine. Another common name also for this, we call as trimethylamine. So this write as dimethylamine. These are the amines, primary amines, secondary amines, tertiary amines. Some examples. Aromatic amines you take. Name is aniline. Common name is aniline. This is common name. Common name is aniline. IUPAC is aminobenzene. Aminobenzene is the IUPAC. These are the different functional groups and their IUPAC and some common names. Common names, IUPAC names of different functional groups. Then priority order. Priority order of these functional groups. First priority group is carboxylic acid. Second one is sulfuric acid. Carboxylic acid, sulfuric acid, and then acid derivatives. You know already acid derivatives. The first ester, acid halide, amide, the acid derivatives. The next one is SPRT group is nitrites, cyano compounds called as nitrates, you know already. Next, carbonyl compounds in that aldehydes, ketones, DRG. Next, alcohols, hydroxy compounds. Next, amines. Next, alkenes. Next, alkynes. With DRG. First PRT group is carboxylic acid. Second one, carboxylic sulfonic acid. Acid derivatives in that order is ester, amide, acid halide, amide. Next, nitrites, nitrogen cyanide compounds. Next, aldehydes, ketones. After ketones, alcohols, amines, alkenes, alkynes. Then after the substitutes, nitro, chloro, bromo, like that we get. Halo. That's the main function. Completed. So first priority group is acid. Acid, sulfonic acid, acid derivatives, nitrates, aldehydes, ketones, alcohols, amines, alkenes, and alkynes. Then open sheet 23. Topic is 23. That question number 4. Question number 4. Please, all of you, take this sheet, previous mains questions. The topic is 23, some basic principles of organic chemistry. The question number 4. They are asking IUPAC name of C double bond O CH CH3 taken twice. How to write clearly? C double bond O CH CH3 CH3. This they are asking IUPAC name. So always you give the least number for functional groups. That's right. 1, 2, 3, 4. 1, 2, 3, 4. Number. Then a third carbon methyl substituent is there. So we write as 3-methyl. So in straight chain, how many carbons are there? 4. 4 means bute. Bute is the root word. So it is the ketone. So we know already. One is the suffix butanone. 3-methyl butanone is the IUPAC name of this compound. Fourth question answer is B. Here, second question, ketone group is there. Next question. So 3-methyl butanone is the IUPAC name. This compound. Next question. Question number 5. What is the name of this compound? They are asking. IUPAC name. They given here 1,1 dimethyl 3-cyclohexanone. Option B they given 1 cyclohexanone is the correct. Dimethyl 3-hydroxy cyclohexane. Option C they given 3,3 dimethyl 1 cyclohexanone. Option D they given 3,3 dimethyl 1 hydroxy cyclohexane. Fail. So always we use the least number for functional group. Here function is alcohol. So first numbering starting from here 1, 2, 3, 4, 5, 6. Okay. So here the third carbon 2 methyl substituent. 2 are methyl substituents. You get 3, 3 dimethyl. So here this alicyclic ring we call as cyclohexane. So in first position alcohol is there. For alcohol suffix is ol. So cyclo, one cyclohexanol. Or 3, 3 dimethyl cyclohexane 1 more. Cyclohexane 1 4. So answer is C. And this answer is C. 3, 3. At third carbon, 2 substances are methyl. So 3, 3 dimethyl, 1 cyclohexanol. Let's take all of your homework. Same page, same chapter only. 23 chapter. Topic is 23. In that, question number 10, question number 12, question number 6, question number 2, 2, 10, 12, 6 are the homework questions. Please solve these questions. This is the homework 2, 10, 12, 6. Same topic 2, 10, 12, 6 and read all of you first year NCERT textbook organic chemistry topic.
Sir, I don't have those things.
Thank you. Homework questions are 2, 10, 12, 6, 23 topic. Is that up class today? You can see tomorrow. All of you take homework questions 2, 10, 12, 6, topic 26, 23. This class we discuss isomerism.